Please subscribe and you can download this code from description below. In Python, you can access the second result set of a stored procedure using the pyodbc library, which provides a convenient way to interact with databases. If your stored procedure returns multiple result sets, you can iterate through them to access the desired result set. In this tutorial, I'll walk you through the process of accessing the second result set of a stored procedure using Python and pyodbc with code examples. Prerequisites. Python installed on your system. The pyodbc library installed. You can install it using pip. Access to a SQL Server database with a stored procedure that returns multiple result sets. Step 1. Import the pyodbc library. To get started, import the pyodbc library in your Python script. Step 2. Establish a database connection. Next, establish a connection to your SQL Server database using pyodbc. Replace the connection string with your own database details. Step 3. Create a cursor object. Create a cursor object to execute SQL queries and interact with the database. Step 4. Execute the stored procedure. Execute your stored procedure using the cursor object. If your stored procedure returns multiple result sets, you can use the next set method to navigate between them. In this example, we assume your stored procedure returns at least 2 result sets. Step 5. Fetch and process the data from the second result set. You can now fetch and process the data from the second result set. Use the fetchAll method to retrieve all rows from the result set and iterate through them. Step 6. Close the database connection. After you have finished working with the database, don't forget to close the connection. That's it. You've successfully accessed the second result set of a stored procedure using Python and pyodbc. Make sure to customize the code with your specific database and stored procedure details. Python 3.0, also known as Python 3, was a major milestone in the evolution of the Python programming language. It brought significant changes and improvements to the language while striving for a cleaner, more consistent syntax. In this tutorial, we'll explore the key features introduced in Python 3.0 and discuss its impact on the Python ecosystem. We'll also provide code examples to illustrate some of these changes. In Python 3.0, the print statement was replaced with a print function. This change improved consistency and allowed for more control over the output. Python 3.0 introduced a new behavior for division. The slash operator now performs true division, returning a floating point result. To perform integer division, floor division, you can use the // operator. Python 3.0 made significant improvements in Unicode handling. All strings in Python 3 are Unicode by default, which simplifies working with non-ASCII characters and different character encodings. Python 3.0 introduced several syntax changes to enhance code clarity and consistency. As mentioned earlier, the print statement was removed. This change aligns with Python's philosophy of having a single, clear way to perform an action. In Python 2.x, range generates a list, which can be memory intensive for large ranges. Python 3.0 introduced range, which behaves like Python 2.x's ecrange, producing values on the fly, saving memory. In Python 3.0, the input function reads user input as strings by default. In Python 2.x, input evaluates the input as Python code. To achieve Python 2.x behavior in Python 3, you can use eval input. Python 3.0 introduced new ways to format strings, making it more versatile and readable. F-strings allow you to embed expressions inside string literals, making string formatting concise and intuitive. The str format method provides a flexible way to format strings by specifying placeholders and filling them with values. Python 3.0 marked a significant milestone in the evolution of the Python programming language. It brought about cleaner syntax, improved Unicode support, and enhanced string formatting. While the transition from Python 2.x to Python 3.x required adaptation, it ultimately resulted in a more robust and modern language. Python's evolution has continued with subsequent releases, introducing even more features and optimizations. Developers are encouraged to use the latest Python 3.x version to take advantage of these improvements and ensure code compatibility with the future of the language. ChatGPT